So now I'm going to show you another method to solve that second example problem. You will see this method pop up on the internet occasionally if you're trying to search for answers and trying to figure out more ways of solving problems. So I just wanted to explain the method. The only thing about the method is that it's a specific method that only works in one scenario. So it works in the scenario where you know these values, because if you know those values, there's a way that you can use the chart without using x's to get to this value right here. It involves a little bit of intuition also when you're doing it. So if you're very process thinking, you may want to just bypass this altogether. Also want to point out that just because you may not like seeing x's in there, it doesn't mean you're going to get away from solving for them. As you move into future lessons, you will have to end up you'll be given k and you'll be plugging x's in and you'll end up with like quadratic equations. I'm just giving you a heads up where we're going with all this. And so it's not a method that will work for other situation, but it does work for this situation. So the situation is where you have to solve for k and you have all but one equilibrium value. So you set it up the same way. So you have your 0.10 molarity and your 0.10 molarity, and that is 0. Then we jump down and we fill in the equilibrium part. So that's 0.03, that's 0.03. And so then what we say is, well, the difference between the two of those is 0.07. The difference between the two of those is 0.07. So that's what was lost. And then over here on the right side, because it's all 1 to 1 to 1, it's what is gained. This is also a little bit tricky if you're trying to use this method and this one isn't a 1. It's a little bit tricky also. But that's how you will solve for the equilibrium concentration of I3. And it's kind of just by thinking about what would be the difference in those numbers. And then this has to be the same because it has all the same coefficients. And then, just like before, you just plug it in. So you have your 0.07 on top and your 0.03 and your 0.03 on the bottom.